Alright, let's talk about how to solve equations using algebra tiles. So we've used algebra tiles a little bit in class now. So let's talk about what it means to actually solve an equation. So an equation means we're dealing with something that has equals in it. And in this case, we have x plus 2 equals 5. So the stuff that's on this side of the equal sign will go on this side of our mat. And the stuff that's on this side of the equal sign will go on this side. So here we have x plus 2, so I'm going to bring an x over. I'm going to bring 2 1s. And then I need to bring 5 1s over here to represent my 5. Okay, so see how this nice little applet tells me if they're equal both here and here? That's how I make sure that I'm doing stuff right. Okay, step 2 says to add or subtract the number with x to both sides. So we have 2 1s right here, so we need to get rid of those by using our zero pairs idea. And what I do to one side of the equation, I have to do the other in order to maintain that equals, that balance, okay? Then I need to simplify both sides. Well, we know that zero pairs cancel each other out. So when I add 1 and negative 1, I get 0. So I'm going to simplify both of my sides. And I am left with x equals 3. Well, you must always check your answer. So x plus 2 equals 5. We got that x equals 3, so I'm going to plug in 3 here for x. 3 plus 2 equals 5. So does 5 in fact equal 5? Yes. Okay, so I went ahead and set up the problem. We have x minus 4. So we have an x and then we have 4 negative 1s. And we have 5 over here, okay? So we need to add, subtract the number with x to both sides. So I'm trying to get x alone, so I need to get rid of these 4 negative 1s. Well, the way that I do that is by adding in my zero pairs. So I need to add in 4 positive 1s, but what I do to one side, I need to do to the other side. So now I've added 4 1s to both sides. Now I just need to simplify. So when I add the 1 and the negative 1, I get zero pairs, which leaves me with x equals 9. Then I need to check my answer. So x minus 4 equals 5. I got that x equals 9, so I'm going to do 9 minus 4 equals 5. Well, 9 minus 4 gives me 5, and 5 does equal 5. Okay, so I went ahead and set up our next problem. So I've got x plus 4, and that equals negative 2. So I'm going to start writing this out because unfortunately we're not going to have our algebra tiles with us when we take our test. So I want to talk about what this looks like if I were to write it out algebraically. So I've written out my equation, okay? Then I need to add or subtract the number with x to both sides. So I'm trying to get my x alone, and I have 4 1s here, which means I need to add my negative 4 to make my zero pairs. And what I do to one side, I have to do the other in order to maintain that equals, that balance. Okay? So what I've just done here is basically subtract 4. And what I did to one side, I have to do the other. And I'll draw a little line so that it's easy to tell. Okay? So I make my zero pairs, so I make these go away, which means I have successfully canceled these out, and it left me with x. And then I just count up my pieces over here. So I have 1, 2, 3, 4, 5, 6 negative 1s. So negative 2 minus 4 gives me negative 6. Alright, for our next problem, I've gone ahead and set up x minus 4, so I have 4 negative 1s, equals 4, so I have 4 positive 1s. Alright, so now I need to add / subtract the number with x to both sides. So I'm trying to get x alone, which means I need to get rid of these red squares. The way I do that is with zero pairs. So I need to make a zero pair here, a zero pair here, a zero pair here, and a zero pair here. But right now they're not balanced, right? We don't have that equal. So what I do to one side, I have to do to the other side. Okay? So what I've done in this case is I've added 4 to both sides. And I'm going to draw that line so it's easy to tell. Then I make my 0 pairs. So I make a 0 pair here, 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 and here. So I have successfully gotten rid of my extra numbers over there, which leaves me with x. And then I've got 4 plus 4, which if we want to just count these up, we can see that we're left with 8. And then I didn't do this in the last problem, shame on me, but I should go back and plug it in just to check my answer. So to check my answer, I'm going to plug 8 back in, so 8 minus 4 equals 4. Well, what's 8 minus 4? 4. Does 4 equal 4? Yes. So we are good. So something I want you to notice is that when we're solving one set of equations, we're doing the opposite operation. And what I mean by that is if we have something like x plus 2 equals 5, in order to get rid of this 2, we have to take it away. We have to make 0 pairs. So 2 minus 2 cancels out, leaving us with x equals 5 minus 2, which is 3. And then if I had something like x minus 4 equals 7, the opposite of subtracting would be adding. So I add 4 to both sides. Remember, because what I do to one side, I have to do the other in order to stay balanced. Well, negative 4 and 4 make 0 pairs, which leaves me with x. So I've got 7 plus 4, which leaves me with 11. So I want to talk about that same idea of opposite operations, but with multiplication and division. So if I've got something like 7x equals 21, right now the operation going on between the 7 and the x is multiplication. Let me try to make that bigger. There we go. So in order to undo multiplication, I need to divide by 7. Well, little bit of recall from our fractions that we love so much. If you have a number divided by itself, that is always 1. Right? So if you don't believe me, put it in your calculator. 7 divided by 7 is 1, which is a good thing because we're not trying to get rid of x, we're just trying to get it alone. And we know that 1x is the same as just x. So I have successfully eliminated my 7 and isolated my x. But what I do to one side, I have to do the other. So 21 divided by 7 equals 3. My answer is 3. But I need to check it, so I'm going to plug it back in. So 7 times 3 equals 21. Well, what is 7 times 3? 21. And it works. Okay, so same idea here. So if we have a number divided by a number, we need to get x alone, which means we need to do something with that 4. Well, right now the operation is division, so the opposite of division would be multiplication. So I need to multiply both sides by 4, because what I do to one side, I have to do the other. Now this again is that same idea that we just talked about. If I were to do 4 divided by 4, that's 1. Again, I'm not trying to get 0 here, because if I had 0 x's, then I wouldn't have x anymore, and I wouldn't have anything to solve for. So I'm just trying to get rid of the 4's and leave my x alone, because 1x is the same as just x. Alright? And then what I do to one side, I have to do the other. So 3 times 4 gives me 12. So this is my answer. But I need to check my answer. So if I plug this back in, I've got x divided by 4, so I plug in 12 for x equals 3. 12 divided by 4 is 3. So 3 equals 3, and we are good to go.